Alright, so relating mass to the number of atoms. A mole is a counting unit, so it's like saying a dozen is 12. A mole is the amount of a substance. It's equal to the number of atoms in 12 grams of carbon-12. Avogadro's number is 6.022 times 10 to the 23rd. So if I have 1 mole of something, then I have 6.022 times 10 to the 23rd of that thing. So if I have 1 mole of atoms, I have 6.022 times 10 to the 23rd atoms. If I have a mole of paper, I have 6.022 times 10 to the 23rd pieces of paper. Molar mass is the mass of 1 mole. So if I take Avogadro's number of atoms, then the mass of it is going to be the molar mass. The units are grams per mole, and it's a decimal number from the periodic table. We're going to always go to 1 decimal place. So if you look at sodium, sodium's molar mass is 22.9877. So if you go to 1 decimal place, it'd be 22.9. The 8, though, is going to round the 9 up to 10, which changes the 2 to a 3, so the molar mass would be 23.0 grams per mole. For oxygen, when we look at the periodic table, it's 15.9994. So again, if we go to 1 decimal place and we round, the 9 will change the 9 to a 10, which would change that to a 6. So the molar mass of oxygen is 16.0 grams per mole. For nitrogen, the molar mass is 14.0067. So if we go to 1 decimal place, 14.0, the second 0 is not going to change that 0, so the molar mass is simply 14.0. Now, not all elements have a molar mass ending in 0.0. So if we look at 3 more examples, magnesium, sulfur, and chlorine. Magnesium on the periodic table is 24.3050. So we would round to 24.3. Sulfur's molar mass is 32.065. So we would round 32.0. The 6 is higher than 5 though, so it's going to be 32.1 grams per mole. And then for chlorine, we have 35.453. So we would say 35.4. The next number is a 5, which is going to round that up, so it would be 35.5 grams per mole. If we have a compound, then we have more than 1 type of atom. We simply add the masses together. So if we look on the periodic table, calcium has a molar mass of 40.1. Oxygen has a molar mass of 16, so that would equal 56.1 grams per mole. In number 2, we have 3 capital letters, so we have 3 elements. The subscript tells you how many of that element. So for number 2, we have 2 hydrogens, so we would say 2 times the mass of hydrogen plus the mass of sulfur plus the mass of 4 oxygens, so 4 times 16. Add all that together, and you would have 98.1 grams per mole. In number 3, we have a 2 on the outside of a parentheses, so that's saying that you have twice what's inside the parentheses, or NH4, NH4S. So you would do 2 times the mass of nitrogen, 14.0, plus 8 times the mass of hydrogen, 1.0, plus 32.1, the mass of sulfur, and you would get 68.1 grams per mole as your molar mass. Okay, so when we go to lab, we're going to have to do some converting between grams, moles, atoms, molecules, particles, and volume, which is in liters. The molar mass is, remember, the number on the periodic table, so we would look there to get our molar masses if we're dealing with grams. Mole is always going to be 1. If we're talking about volume, we would use liters, and it would be 22.4. All other words that you'd see is going to be Avogadro's number. So in number 1, if we highlight what we're given, 2.00 moles of helium, and we're looking for grams. So you start with your given, 2.00 mole helium. Make sure you have 3 things, the number, the unit, and the substance. You would set up your table, The given unit, which is mole, would go on the bottom. The unknown unit, which is grams in this case, would go on top. You would still need your substance, helium. 1 goes with mole. The molar mass goes with grams. So we look on the periodic table at helium, and it's 4.0. So 2 times 4 divided by 1 would give us 8. Our significant figures need to match those in our given number. So we have 3 significant figures here, so our answer would need 3 here. So we would have 8.00 grams of helium. Okay, looking at number 2, we're given 3.5 moles of copper, and we're looking for mass. Now mass is measured in grams, so we're going to be trying to solve for grams. We're going to start with our given, 3.50 moles, and this is of copper. Our given unit on the bottom, our unknown unit on the top. 1 always goes with mole. Molar mass of copper off the periodic table is 63.5. So we would say 3.5 times 63.5 divided by 1. We want 3 significant figures based on our given, so we would have 222 grams of copper. In number 3, we're given atoms of silver, and we're looking for moles of silver. So we would start with our given, 3.01 times 10 to the 23rd. It's the given number. We need the unit and the substance. Our given unit is atom, so we put that on the bottom along with our substance silver. We're looking for mole, so we'd put that on the top. Well, 1 always goes with mole. Avogadro's number goes with atom, so 6.022 times 10 to the 23rd. Again, we're going to multiply the top, divide on the bottom. Make sure that you use that special button when you do your times 10. So in your calculators, 3.01, special button 23, times 1 divided by 6.022, special button 23. We would want 3 significant figures, so it would be 0.500 moles of silver. Okay, and our last 2 examples, we're given 2.75 moles of aluminum, which is symbolized by Al, and we're looking for atoms. So we would start with our given, 2.75 moles Al. Our given unit is mole, so that would go on the bottom. We're looking for atom, so that would go on the top. 1 always goes with mole. Avogadro's number goes with the word atom. And then when we type that in, we're going to multiply the top, make sure to use that special button, and we're going to divide by the bottom. So 2.75 times 6.02 special button 23 divided by 1. We want 3 significant figures, so 1.66. And then there's a times 10 all the way over on the right hand side of your calculator, so make sure you put that in there, otherwise it's going to be the wrong number. The unit atom and the substance aluminum. Finally, we have given the number of atoms of copper, and we are looking for the mass. Remember, mass is measured in grams. So we're going to start with our given, 1.20 times 10 to the 8th. That's our number. The unit is atom, and we need our substance, copper. Our given unit is atom on the bottom. We're looking for grams on the top. Avogadro's number always goes with atom, and the molar mass goes with grams. So the molar mass of copper is 63.5. We're going to multiply the top, and we're going to divide by the bottom, and we're going to make sure to use that special button. So 1.20 special button 8 times 63.5 divided by 6.022 special button 23. Again, we want 3 sig figs based on our given, so 1.27 times 10 to the negative 14. Don't leave off the times 10 if your calculator gives you one. And that's grams of copper.